Hi, the topic of this video is on horizontal parabolas. Let me start by reminding you of the basic parabola that we've learned earlier in this semester. We had the graph y is equal to a times x minus h squared plus k. Do you remember that this is a vertical parabola? It has a vertex of hk. It has an axis of symmetry at x is equal to h, that is a vertical line through the vertex. We know that if a is positive, the parabola is going to open up. And if a is negative, the parabola frowns, right, and it opens down. And so generally the shape looks something like this. Recall also that the domain is all real numbers. And the range depends on the direction that it opens, but let's just say for this particular case that it opens upward, then the range would be from k to infinity. If it opens down, it would be from negative infinity up to k, because remember that vertex is the highest or lowest point on the parabola. And this is also a function, right? It passes the vertical line test. Well, now we're going to turn our attention to equations of this form. X is equal to a times y minus k squared plus h. Do you notice anything unique about those? Yeah, everything has been changed around, and this is actually then a horizontal parabola. We're going to look at the fact that the vertex is still of the form hk. Now notice where the h and the k come from. They're in different positions. And this one has a horizontal axis of symmetry, and it goes through the horizontal line y is equal to k. In this case, if a is positive, the parabola is going to open to the right, and if a is negative, it's going to open to the left. So in general, we're going to look at something that looks like this. The domain is not all real numbers in this case. It is based on what the vertex point is and which direction it opens, but the range is all real numbers. And hopefully this reminds you of something. This is actually two square root functions graphed, right? The upper half and the lower half are square root functions. And that has a lot to do with how we would get the graph of these by hand. So let's look at some examples to make sure you understand everything that's going on with these. So starting with the basic graph of x is equal to y squared. If I was going to do that by hand, I mean, there's several ways I can look at it, but by hand, notice that I have to do something to y to get x. So if I was doing this by hand, I would plug in values for y and solve for x. So x is the square of the value I just entered for y. So squaring negative 2 gives me 4. Squaring negative 1, 1. Squaring 0, 0. Squaring 1, 1. And squaring 2 is 4. And so graphing this by hand, I find the fact that it does fail the definition of a function. First of all, remember that if an x value has more than one y value, it cannot be a function. It is a relation though. So if I plotted these points 4, negative 2, 1, negative 1, 0, 0, 1, 1, and 4, 2. I see these two square root functions I was talking about before. What is the domain of that? Yeah, from left to right, so it's from 0 to infinity. And the range is from bottom up, which would cover all real numbers. Now, how else might you graph this? You could also think of this in terms of solving it for y and see what each piece looks like. If I happen to solve x equals y squared for y, I would have to apply the square root property. So I would get that y is equal to plus or minus the square root of x. So that is y is equal to the square root of x and y is equal to the negative square root of x. that better. Well, the square root of x is one of our basic functions, right? It is this piece right here. The negative square root of x is just a reflection through the x-axis, and that is this piece here. So together, those two make up x equals y squared. Now, what if we have x equals y squared plus 1? How would that impact the graph? Because we've got to think about what's going on with the vertex, how is it shifting, right? We know when we add and subtract things, it's going to move it either up, down, left, or right, but it's actually doing a little bit differently here. So if I was doing this by hand, again, I would plug in values for y, right, and then solve for x, so like -2, -1, 0, 1, and 2. And we already know we have to square it first, then add 1. So if I square it, I get 4 plus 1 is 5. -1 squared is 1 plus 1 is 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. 2 squared plus 1 would be 5. So the graph of this (5, -2, 2, -1, 1, 0, 2, 1, and 5, 2. Okay, so what does that look like? Yeah, horizontal parabola that shifted to the right 1. And do you remember that? It's true that that outside number, even when we had y is equal to a times x minus h squared plus k, that outside number did what we thought it would. In other words, if it was positive, it went up for vertical parabolas. Well, that happens here, though it goes to the right. So if it is positive, it is going to the right, and it takes us our vertex to 1, 0. The domain would be from 1 to infinity. The range is -infinity to infinity. The axis of symmetry, if you want to say that, is through the horizontal line through the vertex, which is y is equal to 0. Okay, so understand what's happening. This number outside of the y variable is really dealing with the x, and that's what happened before. I mean, it's so cool how things are related together. If I can just show you this real quickly, if I had y is equal to a times x minus h squared plus k, right, that k value is affecting the y, right, not the x. It affected the y. Well, when we have x is equal to a times y minus k squared plus h, now this outside number is affecting the x, not the y. So the outside number always impacts the opposite variable that's inside those parentheses. So what would you think would happen here? X is equal to y minus 3 squared. So now we're going to see a change occurring with the y. And do you remember the inside number always did the opposite of what we thought? So this should do what? Okay, y goes up and down, and it's a -3, so we might expect it to go up 3. So let's look and see what happens if we're going to do this. To get the graph, I would have to say x and y. Again, I'm going to put in values for y to find x, so -2. You know what, since we're dealing with a 3 there, let's do values that will take us to see what happens close to that 3. So like maybe I put in -1, 0, 1, 2, 3, and 4. Because we want to be on both sides of that number. -1 minus 1 is -4 squared would be 16. 0 minus 3 is -3 squared, which would be 9. 1 minus 3 is -2 squared is 4. 2 minus 3 is -1 squared is 1. 3 minus 3 is 0. And then 4 minus 3 is 1 squared would be what? 1. Okay? So on the graph of this, okay, 16, -1, I'm not going to worry about. Even 9, 0 is So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 4, 1, 1, 2, 3, 4, 1, 1, 2, 0, 3, and then 1, 4. And so if we drew the graph, it's going to look something like this. So our domain is from left to right, 0 to infinity. Range is all reals. My axis is through the vertex. Well, what is the vertex? Yeah, the vertex of this horizontal parabola is 0, 3. And the axis then would be y is equal to 3. Okay, so it did what we thought it would do. Remember we talked about this, that the vertex would have to be hk. So there's no number out here, so that's 0, 3. We always take the opposite of the inner number. And so this did shift that x equals y squared up 3 units. And you know, if all this confuses you, you can certainly solve it for y and see how it relates to those square root functions. Then you could get the picture that way. But you have to remember how it's translating that original function, or not function, I'm using the wrong word, relation that we were given. Okay, so here I just want you to think about what would be the vertex, what would be the direction that it opens. X is equal to y plus 5 squared minus 3. So the vertex with this would be what? Yeah, negative 3, negative 5. Right, because we're dealing with x is equal to a times y minus k squared plus h. So the vertex is hk. The coefficient a is positive, so that's going to open to the right. So think about the graph, how it's shifting. If we looked at what x equals y squared looks like, this is going to go where? It's going to go left 3 and down 5. Okay. X equals negative 2 times y minus 1 squared plus 4. Our vertex is the outer number 4, 1. And the value of a is negative, so that's going to change the direction to open to the left. Okay. And really that's about all you need to know. You should be able to get these on your calculator. And I have that in the calculator video. You have to go through and solve it for y, apply the square root property, and so on. But other than that, you should be able to distinguish that from, for instance, if I had y is equal to, let's say, 3 times x plus 4 squared minus 7, you would need to know what is the vertex of that, right? If you had all these on the final exam, would you know which one is vertical, which one is horizontal, right? Y goes up and down, so remember y equals would be vertical. X equals, it runs left and right, so that's going to be horizontal. So y equals this is going to be negative 4, negative 7. Positive coefficient, so that's going to open up, right? Okay, and then the other thing that we've talked about related to this topic is circles, right? X squared plus y squared equals a number, so you have to deal with the center and the radius. So I know all these things can get real confusing. So here's one last slide that I'll talk about. If you have x is equal to a times x minus h squared plus k. Oh, no, I'm doing that wrong. I'm sorry. Getting carried away. Let me just start with y, since that's a function one. Y is equal to a times x minus h squared plus k. X is equal to a times y minus k squared plus h. And then x minus h squared plus y minus k squared is equal to r squared. Okay, I can see how this could get very confusing because there's all these h and k's and squares and everything. So when we're squaring the x, okay, we have y equals and we're squaring the x, that's going to be vertical, right? X equals and we're squaring the y, that's going to be horizontal. But when both the x and the y are squared, that's going to be the circle. Okay, so make sure you can separate these in your mind and identify them if they're all mixed in together. If you have any questions, don't hesitate to contact me. Thanks. Bye-bye.